Today we are going to go through lab number 4 on the port scanning. So under this port scanning, we are going to cover the following details. We are going to do some scanning of the ports on the operating systems, to scan the service versions of the apps that are running, to scan for the details of the services, okay, the version, the details, what is the name of the apps that's running in the background, and also to scan for more information about the operating system on the host machine. So to do that, we will need to switch on a few virtual machines. Server 2019. You don't have to log into the Windows server nor the main Linux. You can just leave it like that. As long as it's logged on, it's fine. Okay. We can scan from the Kali Linux directly. So there's really no need to log in to the server 1 to server 4. So next what we'll do is we'll go on to task number 2 to try and scan the target filtered ports. Okay, so in this case, when we say the port is filtered, it means that there is a firewall that is installed on the host machine. It can be a software firewall, it can be a hardware firewall, I don't know. But there is a firewall that is filtering the ports that are coming in and going out the traffic. So in this case, we are going to use Nmap, the tool, to try and do some probing or scanning. So the first thing is we'll start the terminal, this black screen over here. So let me increase the font size of the terminal. Oops. Yeah, hopefully you can see. So next, we are going to key in this command that's listed on the left sheet. So let's type nmap -s big S. Linux is case sensitive. So when you key in the command, you have to be careful. It's case sensitive. So 10 oops, 10.10.10.102. I don't think this is 102. This is what's this machine? Let me check. Okay, address I have config. Oh, this is 10.10.10.8. So instead of 10.10.10.102, I will scan 10.10.10.8 instead. Okay. So 8, because I'm trying to scan this server 1. So for 10.10.10.8, I'm going to, oops, what did I do? Then press enter. Oops, sorry, should be here. Press enter. You need a scan type require root privilege. Oh, okay, I haven't updated the root privileges. So let me just type the command sudo su dash to upgrade to roots. The password is Kali. And then now I'm running as roots on the Kali Linux. So same thing, I'm going to type in the command nmap -s capital S 10.10.10.8. Press enter and wait for the result to come out. So depending on the machine, probably it will take about a few seconds. So I'm using server 1 instead of this one. So for server 1, these are the open ports: port 21, 80, 139, 443, 45, and 8080. So I'll just highlight this open port details, and then I'll drag over to the Microsoft Word document. Okay, so these are the open ports. Sorry? Oh, this one. Oh, because I'm using server 1, so I change it to port 10.10.10.8 instead. This is for server 1. 102, I think, is server 2. Server 2, no, server 3. Sorry. 102 is server 3. But it doesn't matter because as long as you scan, you should get some similar results like this. So these are the open ports that are currently open on server 1. So let's go on to server 4. Okay, server 4 is a Windows machine. So in this case, they will want us to switch on and switch off the firewall. So let's do that. We'll go over to server 4 and log it to the Windows machine. So in this case, my Windows machine, I will log in to my password. And then it will automatically prompt me to log in. This is my Windows server. So I'll go over to the, I'll just close this command prompt issue. Okay, so next I will go over, okay, I'll wait for the server manager to start. Okay, another 10 seconds. Okay, I think it's more or less online now. Still trying to boot up. The IIS is up, file services are up. Where else is still local server? All servers. File server was up. Should be fine now. Okay, so let's go over to the control panel as mentioned on the left sheet. So we'll go over to the Windows Server machine, and then we'll select and search for control panel. Okay, and we'll start control panel. Under the control panel, we'll look for this option called System and Security. Under System Security, we select Firewall, Windows Firewall. Okay, so for now, the Windows Firewall is off. That's why it's red color. Okay, so what we can do is we'll turn on the firewall. So let's turn on the firewall over here. So turn on the firewall and then click OK. So now after I turn on the firewall, the status is now green color. Okay, so let's go over to the Kali Linux again to try and scan the servers. So let me clear my screen. Okay, now I'm going to ping the Windows Server 4 machine. Okay, so I'm ping -C3 10.10.10.102. So as I try to ping, you will see that the result going to come back in about 10 seconds time is not successful. Okay, 3 packets transmitted and 100% packet loss. That means everything is gone. It's not successful. Okay, so record your results in the table below. Are you able to ping 10, 10, 10, 102? No. Okay, so you can just here 3 packets. No. 10 packet loss. Okay, so now let's go back to the server 4 and then disable or create a new rule for the firewall. So we'll go over to the Windows Server, and then this time round, under the firewall setting, we are going to configure some advanced settings. So under advanced settings, we are going to add a new inbound rule. Okay, so this is what you have learned earlier in the server hardening. Okay, so inbound rule. So we go over to the new rule. Okay, new rule option. So let's go over to inbound, new rule, right click. Okay, under inbound, and then we will be able to specify the rule that we want. Okay. So we will select the program type of rule, next, and then we will select what program I want to allow. Okay, so in this case, select all programs. So I'm going to define a new rule that allow all programs to pass through. So after that, click next. All programs allow connection, which is this one, and then type next again. Okay, this time round, I want to select apply to what? Apply to the domain, to public and private. Okay, all three profiles, and then click next. Give you a name for this new rule. I think it's called allow pick. So we'll do that. We'll call the new rule called allow pick. And then I press finish. So now this new rule should be able to configure on the firewall, the new inbound rule. Let me try and refresh it. Okay, so can you see the new rule that we just created? The allow pick new rule. Okay, so this is the new rule. So now switch back to the Kali Linux machine. Under the Kali Linux machine, let's try and ping again the machine. Ping -C3 10 10 10 102, the server 4 machine. So enter. So this time round, we should be able to ping. Can you see? We have the ping results coming out with the TTL as well as the ICMP sequence number. So record your answer in the left sheet. Are you able to ping? Yes. Okay. Why is it able to ping? You can just copy this result here. 3 packets transmitted, 0% packet loss. Drag this inside your left sheet. Okay, quite straightforward. Okay, then after that, we'll go back to the server 4 again. Okay, under server 4, let's create another new inbound rule. Okay, under inbound rule, right click, new rule, and then select ports. Okay, so now we are going to filter based on ports. Then click next. Sorry, click next. Under the ports selection, select specific local ports, and then type 139 and 445. Comma 445. Okay, so once this is done, click next. Instead of allowing the connection, we are going to block the connection. So select block connection. and then click finish. Okay. The rule should apply to all the domains. Give it a name before we end. So the name is called block the connection. Okay. So once this is done, we'll click next or finish. Sorry. And now the new rule is configured. So now with the new rule, then we are going to block port 139 and 445. Let's try and do a ping using Nmap to see whether the port 139 and port 445 are accessible. So let's go back to the time machine. Let me clear the screen. Oops, sorry. Clear the screen. Okay, let's key the new Nmap command, Nmap result 10.10.10.102, which is the server 4 machine. Next, we are going to define the ports -P139. Okay. And then define option --packet trace -n-p. So double dash packet trace. Then the next one will be -n and -p. Take note is case sensitive. So for example, if it's -pn, notice that the P should be capitalized, small n, capital P. So once this is done, you press enter. You should be able to get some results here. So these are the results for the Nmap. Sorry, no space. Let me scan. Okay, so this is the result for the Nmap scan. Filtered. Which bullet point you looking? Or task 4. I'll come over there. Give me a short while. Okay, so this part, after we done the port new rule to block 139 and 445, right? Let's try and scan this port 139. So notice that after I try to scan the port 139 at this address, I will see that the port 139 states is filtered. Can you see? So the state is filtered. Okay. Because over here is filtered. And then what is the port number used by the client to send the packets to server 4? So the port number used for this case is this one. Can you see? 46464. This is the port number. Okay. So this one is for this port. What is the port number used by server 4 to reply? Okay. To reply the server 4. No, reply to the packet request. So this is the send the reply is this. Where is it? This one. Okay, can you see? This is the reply. 4644 46466. Okay. Why do we need to know the port number? Because the port number will be used by the client to perform this action. Okay. So that's the reason why it's filtered. Okay, let's continue on. So for this case, we have done the port 139. Okay. So port 139 is here. So let's do the same thing for the next port, which is port 445. So let me just clear the screen. This time round, I'm going to change the port to 445. Notice that I didn't type out the whole command. I just reused the previous command and changed the port number, that's all, because the command are the same. Okay, so for port 445, when I try to run the scan, this is the result I got. Okay, so port 445 again, because there is a rule on the firewall, so again the state is also filtered by the Microsoft firewall, Windows firewall. So this is filtered. What is the port number used by the client machine to send packets to server 4 machine? So the outgoing port is this one, 36321, okay, because it's the sent portion. So this 36321 is the port number for the outgoing one. And then the next one, for the port number used by server 4 to reply. Okay, so the reply port number is the next one, which is this one, 36323. It may change, depends on your machine. So that's why when you submit for the project or PA, we will ask you to do the screenshots of your answers. Just take note, your port number may not be the same as mine because the port number depends on what is available on your machine. And at the point where they actually perform the action, it may actually be different ports. So just be aware, the port may not be exactly this number, but the idea is the same. So you just want to know which port is being used. So now this is done. So next thing they say revert client machine and server machine snapshot. This means we do not want the firewall. Okay? Remember just now we have the firewall defined for server 4. So basically they just want to remove the changes that we did just now. Okay? Yeah, we can just delete the rule that we just now added. Okay, for example, we added block connection, right? So we just delete this rule. Are you sure you want to delete? Yes. Next one, allow ping, same thing. We just added, so we just remove also. Yeah, that's all. Firewall is already there. It's already warning. We didn't do anything. Oh, what did I do? Okay, so this is for task 2. So let's go on to task 3. Okay, task 3, we are going to examine the UDP ports. Okay, so to do that, we are going to use the client machine, and then we are going to scan the Windows machine. So let's go over to the client machine. I'll clear my screen. Same thing, now we are going to key in this command, nmap dash s capital U. Okay, so the U stands for UDP. Okay, UDP scan. And then dash F, capital F, oops, keyboard dash capital F, 10, 10, 10, 102, and press enter. Okay, so results are available. Record your results in the table below. List the identified UDP ports. So let's see. How many UDP ports are found? All the ports are on ignore state. Okay, great. So there's no port found. 100 open or filtered ports. No response also. No open ports. Why? Is it because my firewall is running? Should have some open ports. Let me check. Probably it's a firewall problem. So let me disable my firewall first. for the Windows Server 4, let me disable the firewall machine, firewall on this machine. So I will disable this firewall, turn firewall off, then click OK. So now my server 4 firewall is off, it's red color. So I can go back to my client and try and scan again. Clear the screen. Scan again. Yeah, usually it takes a long time to scan. So this is also one of the problems you will face during your PA. Okay, so now we have some positive results. Great. So for those of you, if you haven't switched off your firewall, please remember to switch off your firewall for server 4. It should be disabled. So after I scan the client on server 4, I should be able to receive this result. So list the identified UDP ports. I have total of ports 123, 137, blah 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 over here. So let me just paste this on the screen. Identify UDP ports. Yeah, again, it's possible because your machine is a dynamic state. So sometimes, depending on the how many VM you switch on, and also depends on the program that is currently running, you may have slightly different result. But this is generally how we do it. Okay, so next we list the open or filtered ports, which is quite straightforward. That means everything minus the 137. Just include everything except the 137, which is this one. So yeah, all these are the open filtered ports. Okay, so task 3, still have one more. Okay, so we can do the same thing for the other servers now. So for example, I can try and do the same thing on server 1. I think server 1 is 10, 10, 10, 8. So server 1 is 10, 10, 10, 8. So we can do the same thing for server 1. So let me just clear the screen. Never mind, I don't need to clear. Let me run the same scan on server 1, 10, 10, 10, 8. And then I press enter and wait. So it will take some time, depending on your machine, how much RAM you have. For our computer in T307, our computer only has 16 GB RAM. So it may be a bit slower. It's a little bit slower than normal. So as you can see, during the PA, if you are lucky enough, you may have to do a scan that takes maybe 5 minutes or 10 minutes. So time management during your PA is important. Otherwise, you might not be able to finish a PA. Not because you don't know how to do, more because the scan take up the bulk of your time. about 3 minutes, no response. Oh, finishing 99.99 done. Okay. So total time it took about 2 minutes plus 129.86 seconds. Okay, let's take a look at the results for the scan on 10.10.10 in the main Linux. For our case, we have identified some UDP ports. So these are the ports that are currently running on the main Linux server 1. Okay, let's list the UDP services. So these are the services. So the services over here. And BIOS. After that, we have BIOS BGM. Yeah, I have no idea what it means BGM. IPP. And then the last one is zero comment. Okay, so these are the UDP services that are currently running on the main Linux machine. You can do the same thing for the other server 10.10.10.100. I think is server 3, but we'll just skip it because it's actually the same thing. So far, we just keep server 1 and server 4. So let's go on to maybe port number 7. So this time round, we are going to scan the Windows machine, the server 4, but we are going to add a parameter called disable upping. Let me just clear my screen. Okay, so I'll do the same port tin scan. So let me just scan the 102. So this time around, I specify my ports I want to scan. 137 dash SU 102 no dash F, sorry, dash PN and also dash N and what else, disable upping dash disable upping. Oh shit, forgot to disable up ARP. So which means with this parameter or option that we just selected, I think it should be able to run slightly faster because we don't have the upping process. That's reason also. Okay, once it's done, press enter and wait. Your port specification is illegal. Oh, what did I do? Port. Oh, sorry, I missed up. Supposed to have a space in between. Yeah, typo error. Okay, so after this, I just press enter. Okay, so you can see without the ARP ping is very fast, almost instantaneous, 0.11 seconds compared to 2 minutes plus just now. So what is the application that's currently running on port 137? As you can see, the port application is NetBIOS NS, the namespace. What is the reason for the port 137? It is this one, UDP response ETL 128. So this is the reason for this part over here. So as you can see, the labs are quite straightforward. The thing, or probably the most problematic issue, is waiting for the scans to complete. That will take a lot of time. Okay. Otherwise, the rest of it is quite straightforward. We'll do the same thing for the next port 138 for Windows machine as well. So we can press enter and wait. Okay, results are back. Same thing, application service running is NetBIOS DGM. And the reason for the response is there's no response. Okay, this port is not responding because the port is not in use. Okay, it's not in use. so there's no response. So this is my task 3. Okay, let's go on to task number 4. Okay, we're going to use the Nmap to scan for the top 10 TCP ports. So same thing. Over here, let me clear my screen. Okay, I'm going to use the command nmap 10.10.10.102 dash dash top ports equals to 10 and press enter. We're back to waiting again. So scanning usually takes a lot of time, but scanning is important. Okay, that's great. The results are out, 13 seconds. So list of top 10 ports most frequently scanned. Okay, so these are the ports that we include in the top 10 ports. Okay, list the closed state ports. In this case, the ports that are closed. We have this ports that are closed, so we'll delete the open ports. Port 80 is open, 13945 all open. So only 1, 2, 3, 4, 5. 5 ports are closed. List the open state port, same thing. We'll do the equivalent, but this time around we'll just leave the open ports. So open ports. Oops. Okay, so that's about it for this top 10 ports. This option is useful when you have limited time now. You don't want to wait for long hours just to get the result. So you just want to see the most popular ports. They are currently frequently scanned. So these are the top 10 ports. Okay, next we'll do the same thing for the other servers. So let's try for maybe server 1. Okay, server 1 is 10.10.10.8. So we'll run the same command. But this time round, I put it for 10.10.10.8. Okay, same thing, results are on. The top 10 ports most frequently scanned over here is the same top 10 ports. Okay, then we'll take a look at the closed ports. So closed ports, we have the following. We'll delete the open ones. And the same thing for the open ports, we'll delete the corresponding closed ports. Okay, so these are the same port statuses for the 10.10.10.8, the main Linux machine. Okay, so that's for this task number 4, I think. We can skip the rest because they are actually the same commands for 10.10.10.10, which is your server 2, and 10.10.10.100, which is your server 3. So they are more or less the same. Yeah, so I'll skip over to task number 5. So task number 5, we are going to use Nmap to scan for one particular port. Okay, so we can use the Nmap to scan only for one port. So let's try and do that now. So same thing for the Nmap. I'm going to use the command nmap -p. P stands for ports. I want to scan only SMTP, Simple Mail Transfer Protocol, okay, for the email upload. So target 10, 10, 10, 8, and then press enter. Should be quite fast, I think less than 10 seconds. Oh, I'm wrong. It takes quite some time, 13 seconds. Okay, so let's see the result. Port number is port 25. Port state is closed. And then service that is currently running is SMTP. Okay, so this is for the 10.10.8, your main Linux machine. So we go on to same machine, but this time around I'm going to scan another service, which is your MySQL, MySQL database. Press enter. So this lab is basically allowing us to explore the different options for Nmap. You don't have to use all the options for your project or your PA. So it depends on the machine that you are given. It may be slightly different. My service is MySQL. Okay, so this is more or less done. Wow, so many. The below cannot do. Which one? All cannot do. So serious. Okay, let's try a few more. HTTP should be okay. HTTP I think should be fine. Yeah, this lab is quite repetitive. You keep scanning, everything the same, is just the services are different. Okay, so Nmap HTTP services are available. There are two ports. One is port 80. The other one is port 8008. Okay, port states available. You have one open, and the other one is closed. Both the services are running HTTP. Okay. This is a bit unique. I don't know why this machine have two ports running the same service. Usually we only have one. Probably the second one is a backup. Probably, I don't know. But usually we only have one port for this service. Okay, let's try and run the next one. HTTPS SSL. Oh, the rain has stopped. Okay, HTTPS is ready. So let's copy the details. Port number 443. Port state is open. And then service is HTTPS. Okay, let's try and do the FTP. Yeah, sometimes cybersecurity can be quite boring job. You just scan, scan. Yeah. Also, so FTP port number is 21. Port state is open. Then FTP is the service name. Okay, so more or less done. We still have this one, HTTP proxy. I try again, see whether can. I don't know. Proxy. Actually, all the commands are the same. I don't know why they scan so many commands. Finishing page. Okay, I think another one page or so. Okay, results are out. HTTP proxy is running on 8080. Port state is open. And then the service is called HTTP proxy. Okay, we can skip this one because it's going to give more or less the same answer. 10 is server 2. So we just keep it for now because results are more or less the same. Okay, towards the final one, I think this is the last task for this lab sheets, correct? Yeah, last task. So task number 6, we are going to try and scan all the ports. So let's try. Clear the screen and scan the ports for the machine dash p dash. Let's try dash p dash on 10.10.10.8. Oh, I don't have 10.10. So I'll change the question a bit. I'll change scan to 10.10.10.8. Yeah, I'll use 8 to scan because we are running on server 1. You can also try on server 4 as well. Of course, the ports may be slightly different. It doesn't always appear the same. So for me, just for illustration purpose, I use 10.10.10.8 because I'm switching on server 1. So we'll just quit. So 90% of the time, cybersecurity is waiting. Oh, we got new classmate. Hello. Okay, it's up. So the server 1 results are back. So record your results in the table below. Port 21 is FTP, obviously. Port 25, don't have, ignore it. Port 80 is HTTP. 110, not there. 139, not there also. 143, HTTP. The other one is 3306, MySQL, not there. So this one is not running MySQL. Let me see, 10.10.10.8. Hey, wait, just now was running one service. Okay. This is supposed to 10.10.10.100. Oh, okay. Doesn't matter. So the numbers, even if it's different, doesn't matter. We can actually, uh, because different operating systems have different rules or different services they are running. So some of them may or may not be running. It doesn't matter. The last one I'm using because one of them server 1 is 10.10.10.8. So if you're using server 4, you can use 10.10.10.102. I mean, I'm using these two servers now. Of course, if your server is different, you can use your own server as well. Doesn't matter. We just want to try this scanning as exercise as well. Okay? For example, for this case, I'm not getting 3306. I'm getting 8080 for the proxy server, proxy service. So that's why this one you can change it to the TNT. Then this is a proxy service and so on. Also, I can have another insert new row on top. This one is 445. This one is for Microsoft ES. So the services and the ports depend on your machine that you switch on. Okay, it doesn't always mean that the same service or the same ports are going to be active. It depends on the machine you have. Okay, so this is just an exercise that we wanted to try to get the hang of the service that we are trying to scan. Okay, the last machine I have for server 4 is 102. So when I scan all the ports 102 machine, it should come out with the result. Okay, 102 is a Windows server, so it should be able to come out with these ports. Yeah, anyway, sometimes cybersecurity can be quite boring. Yeah. Yeah, you want hacking? Yeah, yeah. You look at DBS, very exciting. Okay. For the past 3-4 days, right, those who work at the DBS IT team is going through hell. Yes, when system down, the IT department goes through hell. No sleep, no rest. Okay, so that's why in the IT so-called career, right, most of the time we pray that nothing happen. When something happen, then you become very happening. I don't know yet. My results still waiting. So the scan will take time. So if you want to know how boring it is, you can ask Mr. Ryan. The job can be quite boring. Of course, boring is good. It means nothing happened. If something happened like DBS, then it become very happening. Unfortunately, yes. You get paid for doing nothing. But if something happen like DBS case, right, then you become very busy.
You don't get paid for doing nothing. You get paid to make sure nothing happens.
Yeah, correct.
It's the other way around.
Make sure nothing happens.
When something happens, you're expert. It's not you get paid for doing nothing. You get paid to make sure nothing happens.
Okay, my machine take a long time to scan. I don't know how long it finish. But anyway, this is the rough idea. So once you finish, you can just populate the information on the lab sheet here to get the results.